talk about multi-layer perceptron. The idea of the multi-layer perceptron is many people talk about this using MLP. The idea is quite simple. In the case that, of course, you know already known that that's in the two-dimensional space. If you have the uh, input from two classes, that is positive and negative. If you have a line here that can be used to separate both classes and completely separate. If in this case we call it linearly separable. It is indicates that you can use a line, a straight line, to separate both classes. And of course, for the if it is one here, it could be this one is the and, right? It is okay, linearly separable again. And for the for one, sorry, this is one. This one is for or. Again, it is linearly separable, but in some cases, you need something else. Like for example, the exclusive or. What is the exclusive or? The exclusive or is this is a truth table of exclusive or. If you have x1 and x2, and this is an output. For the x1 and x2 in the case of exclusive or, if it is true and true, true and false, false and true, and false and false. In the case that the inputs are same, the output is false. In the case of input that are different, the input will be true, the output will be true, sorry. So this one, if this is 1 and 1 and this is x1 and x2, this one will be negative and negative. And for the one that is the input are different, 1 0 and 0 1, the output is positive. In this case, you cannot use a single line to separate all examples. Okay, so you need something like this. You need two lines, and if the input or if the data, if an example is in this area, if it is in this area here, you will classify it as a positive one. And how can we do it? Because we know that a single perceptron can be used to classify it. You can place a single perceptron in a two-dimensional space, and one side will be positive and the other side will be negative. And how can we do that in this case? We need the multi-layer perceptron. The idea is, if you call it the perceptron, if you call it the perceptron number 1 here, if you call it the perceptron number 1 here, and this one is perceptron number 2. Okay, so and we plan that on this side of P1, this side of P1 will be the positive, okay, according to the direction of this arrow. And on this side of P2, it will be classified as the positive. You plan it, and so I use the arrow to represent the direction of the positive decision. Okay, so now if I call it if I name it here, this one is E1, E2, E3, and E4. If I name it like this, the true and true, or true is I will use it again like this. Move it. X1, X2 in output. I use X1 and X2 here, and this is 1, 1, 1, 0, 0, 1, and 0, 0. This is a number that we'll use. So E1 is here 1, 1. E2 is 1, 0. So E2 is here. E3 is 0, 1. So E3 is this example. And the last one is E4. There's 0, 0. So we will have 4 examples. So guys, look at this. If you plan it to be classified as the direction of the arrow, if I draw a new table here, this is X1 and this is X2, and this is the output from P1 and the output from P2, and this one is final output. Look at this. You have X1 and X2 to be 1, 1, 1, 0, 0, 1, and 0, 0. And guys, for E1, look at this. Look at this. For E1 is here, right? For E1, the output of P1, P1 is on this side, right? E1 is on this side of P1, so it will be classified as the positive one, right? Okay, so if it is the positive one, look at this. I will use it to be P1 will be 1, right? The output of P1, when we look at E1, look at this. When we look at E1, the output from P1 is 1. When we look at E2, E3, all of these 3 examples are on the positive side of P1, right? So P1 will be 1 and 1 for E1, E2, and E3. But for E4,